All right, now we're going to talk about section 1.1 from the geometry book, using segments and congruence. So let's learn a couple things before we go on to actual segments and congruence in there. So the first thing we need to learn about is what a coordinate is. What a coordinate is, it's a point that you're given a specific distance, a specific location for. So really, when you're looking at coordinates, you're given the names and you're given the coordinates of the point. So it's a point that has a name and you're given the coordinate, the distance, the location, whatever you're given that unit of value to it. That's what a coordinate is. It's given that unit of value to that point. All right, so let's talk about distance. Now, distance, what you're talking about is how far from one point to another are you going. Now, distance, well, let's look at a couple things here. So if I go the distance from C to D, if you look at that, all you have to do is look at, okay, we're going to take 8 minus 0, and 8 minus 0 is 8, right? So that's 8 centimeters away for those. Well, let's get rid of that. Let's take A and B, and let's not make them such easy numbers. Let's go from 6 to 11. Well, the distance from 6 to 11, 6 to, whoops, wrong piece, to 11, we all can do that one in our heads as well, is 5 centimeters. And how did you do that? Well, you took your distance of one minus the other one, made sure it was positive, and that's exactly what you were doing. Remember, distance can never be negative. You can never go in a distance that is a negative distance. You can go backwards, but you're going backwards in a positive distance. So let's go ahead and let's talk about some more key vocabulary here. Between. I think it's kind of common sense what between means, but what it really means, if I'm going from A to C and B is between them, that means I have to cross B to get to C. If I'm starting at A going to C, if B is between them, if I go in a straight line from A to C, B will be crossed. And what a line segment, or when we're doing segment addition, really what we're doing is line A, or segment AC is going to equal segment AB plus segment BC. Now notice, if you guys notice here, our two ending points there within our names of our segments are actually my names of my segment there. My name of my segment is AC, and it's equal to segment AB plus segment BC. So let's do a quick example there. If I know the distance from FH is equal to 36, and I know FG equals 21, how do I find GH? Well, I'm going to write this out. I know that the distance of FH, so segment FH, is going to equal FG plus GH. Now, do you have to write that out every time? Most likely not. But now I'm going to go look, and I know that 36 is FH, is going to equal FG is 21, and to make it easier so I don't have to write GH, I'm going to change that to a variable plus X. So now all I have to do is subtract 21 from both sides, and really I get X equals 15. That's all segment addition is. All right, what does congruence mean? Well, what congruence means, they are the same. So the same exact thing. When we're talking about segments, if segments are congruent, they have the same length. So if we look at AB, segment AB is congruent to CD, that means the distance is the same. The length is the same. So let's do an example. Are these segments congruent? Well, let's figure this out. How far apart are they? If I have to go from J to K, well, I could go and I could do, if you notice, my Y's don't change, my X's change. I could go and I could do 2 minus negative 3, or I just count 1, 2, 3, 4, 5. So that distance is 5. Now my segment LM there, if you look at that one, it's going vertical, which means my X's don't change. So I could go to my Y's and I could do 3 minus negative 2, or I could just count again. 1, 2, 3, 4, 5. Since they are the same distance apart, that means that JK is congruent to LM. Now I want you guys to notice a couple things. First, that symbol means congruent in math. So if you ever see that symbol, it's an equal sign with a little squiggly above it. That's going to be congruent. And I could write KJ is congruent to ML or vice versa. either way I want to do it, I could do that as well. So I don't have to write it in just that one way. All right, so let's find the lengths of each of these pieces. So using the number line up there, let's find the lengths. So AE, so the difference from 8 to 7, well, we could count out each piece, or we could do, okay, 8 minus negative 7. Well, that's going to equal 15. So this is 15. BC, well, B starts at negative 2 minus 1. Well, that's going to equal negative 3, right? Well, remember, we can't do negative numbers. So this is really the absolute value of that piece. So really, our BC is going to equal 3. And again, if you really wanted to, you could just go up here and count 1, 2, 3. And last but not least, C to E. I'm going to do C first. So 1 minus 8. Well, 1 minus 8 is equal to negative 7. Absolute value of each of those pieces. And what do we get? The distance is 7. All right, do a couple more things here. So segment addition here, a little bit of trick on it. So what is the length of EG? Well, if we look over here, we know that EF plus FG equals EG. So let's write that down, what I just said. I know that EG equals EF plus FG. Not forgetting to put my symbols so we know those are segments. Let's fill in what we know. We know EG is 1.6x. We know that EF is 6, and we know that FG is x. So let's just solve from there. If I subtract x from both sides, I'm going to be left with 0.6x equals 6, which means I have to divide by 0.6 to get rid of that on the left side there. Feel free to use your guys' calculators for that. I know that x is going to equal 10 for that. But the question asks, what is the length of EG? It doesn't ask to find x. It asks to find EG. So now I need to go back and I need to plug it into that point right there. So really we need to plug it in to see what 1.6x equals. So EG equals 1.6 times 10. So EG is actually going to equal 16. And there's our solution. Now between. So T is between R and P. Draw the picture. So we know we have 2 points. We have R and we have P. Those are going to make a line that goes through them. Sorry, my line's not very straight. Now we need to go and we need to put T between them. Remember, if I'm starting at R and going to P, that means I have to hit T. So there is my T. Now does it have to be right there? No, it can be anywhere in between those. That's all we need to do. So now if RT is 2x minus 5, PT is 27, and RP is 5x plus 10, find T. Or find x, sorry. So let's fill in what we know. RT, well that's this part right here, is going to equal 2x minus 5. PT equals 27. PT equals 27 there. And RP equals, so this whole thing equals 5x plus 10. So now all we have to do is solve it, just like we did that previous problem, is solve the pieces that we know. We know that RP, whoops, not RR, RP equals RT plus PT. It's okay that I write that way, isn't it? It's the same thing as TP. So now we fill in our pieces that we know. We know that 5x plus 10 equals 2x minus 5, and I'll put that in parentheses, plus 27. So now I'm going to do some simplifying. Negative 5 plus 27. So 5x plus 10 equals 2x plus 22. I'm going to subtract 22 from both sides. So then I get negative 12, 5x minus 12 equals 2x. I'm going to subtract, and I'm going to bring it up here so you guys can see it better. I'm going to do 5x minus 12 equals 2x, subtract 3, or 5x. Sorry, jumping ahead of myself there. And we get negative 12 equals negative 3x. Divide by negative 3, and we get x equals 4. Now the question said to find x, so all we have to do now is circle it, and we are done. So that's all I'm going to do for this video. Let me know if you guys have any questions. Rewatch anything you need to. Pause it when you need to.